So in continuation to previous lecture, today we will see the last model, that is fundamental model. In this fundamental model, what is we will see interaction model, failure models and security model, because they provide extra services to the distributed computing environment. By interaction model, we will begin with the interaction model. It says interaction model means how the processes are communicating, how they are interacting among themselves. That is, the processes interact by passing messages. The communication may be information flow and coordination, that is synchronization and ordering of the activity. We can say the process will synchronize with the other process, or the ordering of the activity between the processes. Communication takes place with delay of considerable durations. Accuracy with which independent process can be coordinated is limited by these delays. So, uh, because of the communication delay, the accuracy of the independent processes, uh, these independent processes may be limited, and by difficulty of maintaining the same notion of time across all the computers in the distributed environment. The behavior and state of distributed system can be described by distributed algorithm, that is, the steps to be taken by each interacting process and transmission of message between them. State belongs to each process is completely private. Then, performance of communication channel. The performance is measured on three parameters, that is latency, bandwidth and jitter. By latency we means the delay between the start of message transmission from one process and the beginning of the receipt by another. That is the latency, that is the time delay between the start of the message transmission and the beginning of the receipt by the recipient. Bandwidth of the computer network, the total amount of information that can be transmitted over a given time. And the third parameter is the jitter, that is the variation in time taken to deliver the series of messages. Uh, so this is by these parameters we measure the performance of communication channel. Then computer clocks and timing events, because they are working on the distributed environment. So this is also one of the important thing. That is, the first thing is clock drift rate, the rate at which a computer clocks deviate from a perfect reference clock. That is the drift between the reference clock and the computer clock. That is clock drift rate. Now this interaction model is of two types, that is there are two variants. One is synchronous and another is asynchronous. As the name suggests, the synchronous means the different distributed we can say nodes, they are synchronized by a clock, or they are bound together by timings. Asynchronous means they are free. So in this synchronous distributed system, the time to execute each step of process is known lower and upper bounds. So the bounds are fixed. Each message transmitted over the channel is received within a given within a known bounded time, and each process has a local clock whose drift rate from the real time has a known bound. So this is the synchronous. In the asynchronous system, there are no bounds. Process execution speeds. There is no bound of message transmission delay, and there is no bound of clock drift rates. Then failure models. The failure model means the fault occur in any of the computer, including software faults or the fault occurs in the network. The failure model defines and classifies the faults. Omission failures. The process or communication channel fails to perform action it supposed to do. That is your omission failures. Process omission failure of the process is to crash. Crash is called fail stop. If other process can detect certainly that the process has crashed. Communication omission failure. Communication channel does not transport a message from P's outgoing message buffer to Q's incoming message buffer. This is the communication omission failure, known as dropping of messages, send omission failure, receive omission failure, and channel omission failure. It is shown in this diagram. All failures so far are panic failures. These are certain arbitrary failures: fail stop, crash, omission, send omission, receive omission, and arbitrary. These are the class of the failure, the effects, and the description. So you can see from this particular slide all the arbitrary failures, their effects, and uh, the description of the particular failure. Then there are certain timing failures applicable in synchronous distributed system. The class of failures are class performance, clock performance, process, and the description. The clock process local clock exceeds the bound on its rate of drift from real time. Performance, that is the process exceeds the bound on interval between two steps. Uh, and the channel, the message transmission take longer than the stated bounded. So these are related to the timing. Then masking failures, that means knowledge of failure can enable a new service to be designed to mask the failure of the components on which it depends. That is new services, but how these services will interoperate, that fails, that thing fails. And reliability of one-to-one communication, that is the validity and the integrity. How reliable one-to-one communication is, you can see from this particular slide. So this, in the next lecture we will discuss the security model.